For my question, I had a piece of wire 40 centimeters long is to be cut in two. One piece is bent to form a square and the other is bent to form a circle. Determine the length of each piece of wire so the sum of the areas is a maximum. So here we have a 40 centimeter long wire. So first, it's bent to two, so one's forming a square and one is forming a circle. So let's find the area of the circle first. So the equation of the perimeter of a circle is 2 pi r. Since we have a 40 centimeter long wire, we're going to isolate r, so we'll divide that by 2, which will be 20 equals pi r, and then move the pi over to the left side, which will be 20 over pi, which is equal r. So we have r right here. So r is 20 over pi. So let's find the area of it. So just to see how it works, so area equals pi over r area equals pi r squared. So we'll substitute r into the area equation, which will be pi 20 over pi squared. So we'll multiply that, so it will be 20 pi over pi squared, and then 20 squared, and then 400. So
okay, come in quietly,
now our radius is 20.
Mr. Vogel, keyword there was quietly.
So since our length is 20 already, 20 is used on the line on the wire that is used to form a circle. So minus 20 from the 40, which will equal 20. So 20 is the total length of what the square is. So we also have to find x and y, so that's not where we stop. So plug that into our perimeter equation for the square. Okay, 20 equals 2x plus up by 2y. So we'll isolate 2x, so it'll be 2x equals 20 minus 2y. And then we'll divide it by 2 on the right side, which will be x equals 10 minus y. And then we'll find the area of it, which is xy. We'll plug the x into the area equation, which will be y 10 minus y, which will equal 10y minus y squared. We'll find the derivative of that. Because when we find the first derivative, we'll want to equal it to 0 or find a critical point, and then from that critical point we'll see the number line to see if that number is a maximum. So we'll take the derivative of that, which will be 10 minus 2y equals 0, will equal to 0. So we factor it out, which will be 2, 5 minus y, and then y will equal 5. To check if it's a maximum, we'll put it into the number line. So anything below 5, let's say 0, it becomes a positive. Anything above 5, which, like 10, will be negative. So from maximum to minimum, or from positive to negative, this will be. If it's increasing and then decreasing, the 5 will be a maximum. So we'll plug in 5 into this equation right here, x equals 10 minus y. So y will equal 5. So we'll plug 5 into the y, which will be x equals 10 minus 5, which will be x equals 5. So now we have our y and our x's, which is 5 each. So this is our perimeter, 5, 5, 5, 5, which equals 20. And then we have our radius of 20. And then the total length will be 40 centimeters long. So that is our maximum. So for our area is like 25 for the square, and then our area for the circle will be 400. So it will be 425 area. And then 5, 5, 5, 5, which will be 20 centimeters perimeter as for our square, and then 20 as our radius as our circle, so it will be 40 centimeters long total. And yeah, that's how you find the maximum area of a square and a circle combined from a 40 centimeter long wire. Thank you.